NETL's presence in Albany, Oregon traces its origins to 1943, when President Franklin D. Roosevelt announced that Albany was selected as the site for the new Northwest Electrode Development Laboratory. Now, well into the 21st century, NETL's Albany Research Facility is on the cutting edge of metallurgy and materials research. NETL Albany employs 126 staff members across 38 buildings, which includes facilities with bench and intermediate scale metals fabrication and melting capabilities. The campus also supports a full complement of metal processing and materials characterization, materials performance capabilities, and computational resources necessary to design and engineer new structural materials, along with advanced subsurface technologies. NETL also works to advance a new era of direct power extraction via a promising technology to advance high-efficiency coal power generation using a device called a magnetohydrodynamic MHD power generator. The MHD generators can be operated at very high temperatures, which means they can be highly efficient. The high temperature capability of MHD generators is particularly synergistic with the oxy-fuel approach to carbon capture, which uses pure oxygen rather than air to burn fuel. Anchoring NETL's capability in structural materials research is its substantial alloy fabrication and performance testing facilities. These deliver high-performance, affordable materials that enable diverse energy technologies. One highlight of the important work carried out at Albany is NETL's metals melting facility, which is used to formulate unique alloys designed for use in extreme environments that can potentially range from the vacuum of space to the crushing pressures of the deep ocean. Metals are developed in the laboratory's high-temperature furnaces, and molds are used to create the resulting alloy into ingots, which are then heat-treated to homogenize the structure. Another example is Albany's Metals Fabrication Laboratory, which engages in the research to produce into plate and other shapes needed for assessment of new alloys for use in energy-related applications. Ingots come to the laboratory from on-site melt operations and are formed into plates, sheets, rods, and other shapes. The techniques employed mimic industrial manufacturing processes, resulting in useful microstructures that are key to evaluating the material's performance. Most operations in the laboratory are considered hot working and are performed on heated materials. NETL Albany's high-pressure immersion and reactive transport (CHIPIRT) laboratory is a multifunctional, state-of-the-art facility capable of performing geological studies at simulated depths up to 10,000 feet, providing an experimental basis for modeling of various subsurface phenomena and processes. The laboratory also includes several flow-through systems that can simulate carbon dioxide, CO2, enhanced oil recovery, CO2 water-rock interaction of core samples under CO2 storage conditions, and stimulate the interaction between drilling fluids and the borehole wall. In addition to capturing and storing CO2 emissions, NETL and its partners in academia and industry are also committed to exploring new uses for CO2 that could have an economic payoff in the future.